In my book, I referred to this type of problem as the bane of all college algebra students. It's not that bad, but these can turn into pretty long problems, and there are some very easy ways to really screw this up in a serious way. And so I'm gonna pay close attention to this problem, because I want to point out to you the errors people make in it. And so it turns out we're going to need to square both sides of this equation 2 different times. And when we do that, we will create I think we're going to create a quadratic equation when we square it twice. So this is sort of a quadratic form in disguise when we solve it. All right, now, first of all, there are two main approaches here. Now, a lot of textbooks will take one of these square root terms and put it on the other side, isolate it. And so I think I'll do it this way, because in my book I didn't do that. In my book I took a similar problem to this and I squared this side of the equation with the 2 square roots in it and worked it out. And that's perfectly fine. There's nothing wrong with that. To me, I see no big difference in them. But for some reason, textbooks tend to take one of these square roots and they separate them. All right, so I'm going to separate it just for variety's sake, different from my book. So we end up with, I'll keep the square root of 2x plus 3 on this side. On the right side, I'm going to have 5 minus the square root of x plus 1. So I subtracted this term from both sides, which is why it shows up as a negative. All right, now if I square both sides of the equation, that will eliminate this square root. So I'm going to square this side and that side. And as I've discussed before, there's a potential flaw in this solving process. When you square both sides of an equation, you create a potential for error that we have to guard against. So when we get done with this problem, we need to check to make sure our answers worked out. Okay. All right, now when I square a square root, that's going to cancel. It leaves 2x plus 3. Now what happens on the right side? And well, we're squaring the entire right side, which means I'm squaring this binomial term. So I have 5 minus the square root of x plus 1 times 5 minus the square root of x plus 1. Which means I have to multiply this out using distribution. Often that's called the FOIL method. So I'll go ahead and do that. So when we FOIL this, we get 5 times 5 is 25. And then I have minus 5 times the square root, minus 5 square roots of x plus 1. And here's another minus 5 square roots of x plus 1. And then finally this term is going to be this negative times that negative. That cancels the negatives. And I have this square root times that square root times itself. And that cancels the square root, leaving a positive x plus 1. So that was the FOIL method applied to this. Now here's a big mistake people make. Well, first of all, let me finish collecting terms here. So I get 2x plus 3 equals to 25 plus 1 gives us 26. And then I have minus 10 square root of x plus 1, because there's negative 5 and negative 5. And then I have a plus x. All right, here's the big mistake people will make. Those that don't practice, they must not be practicing, otherwise you would think they would try to figure out why in the world they got their answers wrong when they get wrong answers. When you square this side, it's not the same as just squaring each term, not the same. In other words, you don't get 5 squared, 25, you don't get x plus 1. You do get those, but you also get these middle terms because of the distribution. So it is a huge, huge error to take an exponent and distribute it inside an addition or subtraction inside parentheses. Big error. I usually give no credit for that. It's just it's such a devastating error. There's no chance to make any other real progress in the problem. So don't do that. All right. Pay attention to me on this. Don't square each term. And to make a big deal of this, I'm going to give you a numerical example. So I'm going to sidetrack for just a moment and look at this. If you had 2 plus 3 squared. All right. Well, we know that's going to be 2 plus 3 is 5. 5 squared is 25. Great. That's not the same as 2 squared plus 3 squared. In other words, I can't distribute the 2 to both of these numbers. Because 2 squared plus 3 squared, 4 plus 9 is 13, is not the same as 25. And so this mistake here would be equivalent to doing what I was talking about up here. Just distributing the errors. So don't do that. That's a very serious algebra mistake. And I might not even give you any credit for it because I just think it's so fundamental. You're just supposed to know that. Okay. All right. And if you've done any practice and doing it the wrong way that way, then you'll never get any problem correct. And so, okay. Well, now let's go from here. All right. Now, where do we go from here? I have 1 square root left in the problem, and so we went from 2 square roots down to 1 square root. And that's excellent because with 1 square root, I can isolate it on one side by itself, and then when I square the problem again, that square root will disappear. And there goes our problem with the square roots. So our whole strategy is revolved around squaring the equation in the right way so that the square roots eventually disappear, and then we have something that's quite workable. All right, now, so I'm going to keep this on the right side, and let's bring the x over. I'm going to subtract x from both sides, so that would give us x here. And I'm going to subtract 26 from both sides, so I have 3 minus 26 is minus 23, equals to negative 10 square root of x plus 1. So, again, I subtracted x from both sides. I didn't write that step in, because this is college algebra, most of you are pretty good on this by now. But if you need to, write these steps in. Subtract x from both sides, disappears on the right, I get x. Subtract 26 from both sides, this cancels. 3 minus 26 is minus 23. Alright, so I have the square root, and the negative 10, we'll have to handle that too. So to work this problem, I'm going to now need to square both sides again. And does not mean square these terms. It means to take the entire left side and square it, and take the entire right side and square it. Alright, now when I square this, it's going to be a mess, so I'm going to end up with, well, first let's write out x minus 23 times x minus 23. The right side, when I square negative 10, don't forget, this also gets squared. I'm going to get positive 100, and the square root disappears, leaving x plus 1. So I have x minus 23 times x minus 23 equals 100 times parentheses x plus 1. And that may look pretty bad to you, I don't know. But it doesn't look too bad to me, we just have to work it out. But I do need some room, so I'm going to erase everything but the original problem. I need the original problem up there because I want to check my answer when I get done. And so, now I haven't worked this problem before, but I did rig it. I do know an answer to it because I designed the problem with that particular answer in mind. However, I'm looking at these big numbers, and this looks interesting to me how I'm going to get a small answer out of these big numbers. Alright, so on the left side, when I follow this, I get x squared. I get minus 23x, another minus 23x, and then a plus positive, the negatives cancel, 23 squared. And let's see, what is 23 squared? I think it's 529. I want to double check that just on my calculator to make sure. I think it's 529. Yes, it is. Okay, that's good. so plus 529 equals to, we'll expand this out, 100x plus 100. All right, now this is minus 46x, and when I subtract 100x from both sides, I get minus 146x. And then 529 minus 100 is 429. And this ends up being equal to 0. So what I did was I combined terms and I transferred everything to the left side, and so it's been simplified into a quadratic equation. And now that, if I have not messed up anything, this can be factored. And it's not too obvious to me how to factor it, but you could use the quadratic formula on it. You probably want to use a calculator because you're going to end up with some big numbers using the quadratic formula. And but I believe that 3 was an answer to my problem. So 3 is an answer, then x minus 3 is a factor. So if I divide 3 into 429, I get 143, I think. So 429 divided by 3 is 143. Equals to 0. Okay. Let's double check that factoring. All right, so here's x squared. Minus 143 minus 3 is minus 146, and then plus 429, because 3 times 143 is 429. All right, now I wouldn't expect you to just immediately factor that. Knowing that I was supposed to get a 3 as an answer, I knew what one of the factors was. So I think if you were faced with something that large, probably the quadratic formula would be the practical way to go, and with a calculator in hand. But what are the roots of this equation? Well, x minus 3 equals to 0. X minus 143 equals to 0. And so solve here, I get x equals to 3 and 143. So there are my two answers. I want to double check to make sure those are both right. Now I'm feeling pretty confident that 143 is not going to work. I just think it's too big. And so let's check it just to be sure. All right, so I'm going to erase all this other stuff to have room. And check. When x equals to 3, I get the square root of 2 times 3 plus 3 plus square root of 3 plus 1 equals to 5. 6 plus 3 is 9. Square root of 9 plus square root of 4 equals 5. 3 plus 2 equals to 5. Okay, that's correct. So that one works. Let's try the 143. And we get the square root of 2 times 143 plus 3 plus the square root of 143 plus 1. All that equals to 5. Alright, so this is what? 286 plus 3 is 289. Square root of 289 plus the square root of 144. Now the square root of 289 is exactly 17, and this is exactly 12. So 17 plus 12 equals to 5. No, of course it doesn't. And so this is a bad answer. We'll have to exclude that from the answer to the problem. And so there's one of those cases where because of the nature of this solution method has a weakness in it. Squaring both sides of the equation has the potential of creating a bad answer. That's exactly what happened here. We got definitely a bad answer, and and we can only know that by checking it afterwards. So that's what I want to impress upon you. You need to check these answers. All right, so let's write the final result of the problem, and I'm going to circle it because I want if I was writing this for someone else, I want them to be real clear about what my answer is. X equals to 3. There's only one answer to this problem.